Hello, everyone. This is Elisa Baum. I'm GridGain's Director of Product Marketing. We will begin in just a moment, but first I'd like to conduct a bit of housekeeping. Could you please raise your hand using the hand icon located in the GoToWebinar control panel to let me know that you hear me? Okay, great. Thank you. Next, during this webinar, you will be on mute, but should you have any questions during the discussion, please go ahead and enter them in the questions field within the control panel. At the end of the webinar, we'll take time to answer as many questions as possible, and those that aren't addressed, I will send them to the speaker and he will be able to reply to them via email. So don't despair if we don't have time to get to everybody's questions. In addition, a recording of this webinar will be made available to everybody within 48 hours, and I'll also send you a link to the slides. I'd like to thank you for attending today's webinar, Distributed In-Memory SQL Queries in Apache Ignite. It's being presented by GridGain Product Manager, Dennis Magda. And with that said, Dennis, I'll turn the floor over to you.
Hello everyone. Thanks, Alisa, for the introduction. And a couple of words about me. I'm a product manager at GridGain System. Also, I'm an active contributor, and even more, I'm an active committer and PMC member of Apache Ignite project. And today, regardless of the fact that presently I take role of a product manager here at GridGain, I'm really technical person who contributed a lot to both Apache Ignite and GridGain, and I'm going to cover and to tell you a bit more on details on how Apache Ignite works, and specifically we will spend most of our time covering such a fancy feature as distributed in-memory SQL queries that is available in Apache Ignite distributed platform. So let's have a look at our agenda. I guess that most of you already know what is Apache Ignite, or at least have an experience with different distributed data fabrics or distributed data grids. But in order to be able to be sure that all of us are on the same page, I will give you a brief introduction, a brief overview of what Apache Ignite is. And after that point, we will switch to the main topic of our discussion, covering Apache Ignite SQL engine. We will start from the core of our engine, and I will answer on the questions like how the queries are being executed, how Ignite SQL engine builds execution plans, how it what the engine uses in order to optimize or to parse queries, and so on and so forth. After covering such internal material, we will keep discussing the engine, looking at the API that is available for all of you, and how this API can be used, and what are advantages and disadvantages of a specific APIs that are available. To finalize, and I will finalize my talk covering and sharing with you a couple of tips and tricks, a couple of performance optimizations and suggestions that I had in mind, have in my mind after helping out a bunch of Apache Ignite users and customers during the time when they were trying to build and to use Ignite SQL engine in practice. And also, I want to shed some light on the future of Apache Ignite SQL engine, and covering and sharing with you a roadmap that Apache Ignite community has, and how this roadmap, how the new features that will appear soon as a part of Apache Ignite will make the engine, the SQL engine, is even more flexible and more usable for a variety of use cases. And the final thing that will be shown during the talk is a demo. I will show how you can connect to a cluster of machines from a management console and how you can execute and debug SQL queries directly from the console side. Okay, let's start our talk covering the basics of Apache Ignite in-memory data fabric. So Apache Ignite in-memory data fabric is a distributed platform that is built with a notion of horizontal scalability. All this allows your application, your services to scale out and avoid a variety of performance boosts that you may have if you still keep using conventional databases as persistent storages. The system is based on a couple of core components, and among these components we have clustering component, which is actually responsible for which is essentially responsible for building a cluster of your nodes. And it means that using this component, you can start a variety of cluster nodes that are spread out across different machines that can be located even in different geographical locations. And the clustering module will make sure to assemble a single cluster from all the machines that are spread out across a variety of locations. And next, when the cluster is up and running, you are ready to store data in this cluster. And here is where we use data grid component. The data grid component is based on a cache concept. The data is stored and located in caches, which is in general a key value storage. And you can consider it as a distributed hash map or hash table, with the only difference is that the data will be located and spread out uniformly among all the cluster nodes you have in your deployment. Next, there are additional components that are widely used by community and different solutions like Compute Grid, that is Ignite's fork join or MapReduce framework that allows you to send distributed computations to remote machines. Then the streaming component is usable for scenarios when you want to stream finite or endless streams of data into Apache Ignite Data Grid and process these streams of data in real time. Also, Ignite has a feature that distinguishes it from the other data grid, and the feature is called a Hadoop accelerator, which is usable for scenarios when some application uses Hadoop and wants to speed up the Hadoop, and here Hadoop accelerator provided by Ignite can help you out. Next, from the application point of view, Ignite provides a variety of APIs that are available for such major technologies and languages like Java, .NET, and C++. And it worth to mention that the platform is fully built on top of a Java virtual machine. And the most up-to-date and the most fresh APIs we have are available first as a part of Java library, and then they will be imported to .NET and C++. Even more, you are not bound to Java, .NET, and C++ APIs if your goal is simply to execute SQL queries on top of Apache Ignite cluster. You can connect to Apache Ignite cluster from using JDBC or ODBC driver and execute SQL queries right away from your favorite tool or from other technology or language like Python or PHP or whatever else. So, and this is kind of a brief overview on what the platform is. And let me elaborate a bit more on in-memory data grid module. So as I mentioned, the in-memory data grid is based on in-memory caches that store the data as key value tuples in a distributed fashion, spreading the data among all the nodes that are available in the cluster. It's important to emphasize that Apache Ignite data fabric is widely used in financial institutions and organizations. And this is the reason on why Apache Ignite treats data consistency as a high priority feature. It means that Apache Ignite is a strongly consistent system and it's SID compliant, meaning that if you start or execute transactions, modifying data, even locating in different caches, you can be sure that all your data will be consistent, and Ignite will take care of the situations, making sure that a transaction will be either committed or will be rollback. Also, it's the responsibility of Ignite to take care of high availability and data reliability of your cluster. And the last thing I want to highlight here is our distributed SQL engine that in fact distinguishes Ignite from different in-memory data grid solutions or platforms you can find in the market of in-memory solutions. And let's take a look at what are the benefits and what are the differences of Ignite's SQL engine. First of all, it was to say that Apache Ignite SQL engine is fully ANSI 99 compliant SQL engine. For you and for your application, it means that if you migrate your application from the usage of a conventional relational database to Apache Ignite cluster, then for you there is any need to rewrite all your SQL queries from scratch. You just need to set up your cluster. You just need to set up your configurations, and you are ready to run, and you are ready to work, and you are ready to start executing the SQL queries. And here you can, as it's shown on the slide, ANSI 99 SQL specification, make sure that all the aggregations, group by or sorting clauses are supported. As well, joins, unions are also in the scope of Ignite SQL engine. And even more, everything that is supported by Apache Ignite SQL engine is supported in a distributed fashion, meaning that if you want to join data between two caches that have their data spread out among different nodes, then Apache Ignite engine will be able to join this data properly. It will be able to map the query to valid nodes, and it will be able to reduce the results, the final result set, combining it and providing it to your application layer. And even more, during the time your SQL queries are being executed over the cluster cluster may be unstable, meaning that a new node can join the cluster, or some old node can leave the cluster by some reason. And during such cluster topology change situation, you should not expect that you will get an inconsistent result during by SQL query execution. SQL engine will make sure that all this situation, all fault-tolerant related situation will be processed properly, and in all the cases you will get a consistent and valid scenario. Next, it doesn't make sense to use SQL queries if engine or database or data grid doesn't provide support for doesn't have indexing capabilities, because otherwise you can the execution of your SQL queries can take extremely long time. And for sure, Ignite SQL engine is capable is a rich platform that have advanced indexing capabilities, and I will cover a bit later to you how the indexes are supported and can be used from your application layer. Okay, so let's plunge into the details, into the implementation details of Apache Ignite SQL engine. And here I should start the talk by mentioning H2 database. Some of you may be surprised why H2 database why are we talking about H2 database during the webinar? But to be honest, there is a relationship between Apache Ignite SQL engine and H2 database, in a sense that Apache Ignite leverages from some of components that are available in H2 to make the SQL engine more optimal and more applicable for a variety of use cases. So what's H2 database? H2 database is a fast and memory and disk-based database engine. So this database is purely written in Java and available under an open source license. This database has already recommended itself and being used in a variety of projects. And here in Apache Ignite community, we decided to use this database to address a variety of tasks that are needed to be done by our Ignite SQL engine. The first thing that is being used by Apache Ignite SQL engine is H2 database SQL query parser and optimizer. And next, also Ignite uses H2's query execution planner and finally implements specific indexing related interfaces that tightly integrate H2 and Apache SQL Ignite engine for the cases when Ignite needs to build a query execution plan with the help of H2 database, and H2 database will talk to Ignite's indexing implementation modules, getting more details and more information on what indexes are available for a specific query, and all this stuff will result in a final and the most optimal execution plan. So how H2 database is being started, and how do we launch H2 database? So every Ignite node that is started by your application also spawns H2 instance inside of your process, inside of the process where Ignite node works. And next, but in any case, a valid question or kind of reasonable question can arise. Why Ignite SQL engine doesn't use H2 database as is? What is the reason why Ignite uses only some of the components available in H2 database? Why not to rely on the H2 database in general? So, and the answer is really simple. So H2 database is not designed to be used for key value storages. It's still a column or row-based relational database that is mostly used by relational by the scenarios when you want to store data in a relational fashion. But since, as I mentioned earlier, H2 database provides flexible indexing interfaces, and it doesn't prevent us from implementing these indexing interfaces and to use H2 database along with Apache Ignite key value storage. And finally, H2 database is not a distributed engine, which means that if you want to execute an SQL query over the number of the nodes of your cluster, then H2 database won't be your case. H2 database won't be able to execute the queries of all the cluster nodes that are available. So this is what's supported, and this is the part of the story that is implemented by Ignite SQL engine. So here I should say that, as it's shown on the slide, Apache Ignite SQL engine provides and implements its own distributed mapper and reducer for the queries. In addition, the engine takes care about fault tolerance and consistency and provides sophisticated indexes implementations. However, I want to emphasize that regardless of the fact that Apache Ignite SQL engine uses H2 database parser, optimizer, and query planner, it doesn't mean that data is stored on H2 side. That's not true. All the data, all the indexes are stored in Apache Ignite data grid. So there is no any code duplication. The only thing that is used, as I already told, is that H2 is used at the time the query is being parsed and being prepared for the execution. So next, let's look at what kind of indexing implementation Apache Ignite SQL engine has. So first of all, it was to mention that the SQL engine makes it feasible to define both single field and group indices. As it's shown on the code example on the right of the slide, you can see that the first approach on how you can define your indexes is to annotate the fields of your data model objects. For that purposes, we have query SQL field annotation. And using this annotation, you simply mark the fields that should be indexed or should be queried inside of the implementation of your data model object. However, there is one more way that is more generic and that doesn't require you to define everything in the source code, and that approach allows you to define all the configuration, including indexes and the fields that will be queried, that are possible to query directly from the configuration. If we talk about Java, then it can be defined in Spring XML configuration. If we talk about .NET, Apache Ignite .NET component, then you can define indexes directly in app config file of your .NET application. So as for the specific implementation of the indexing interface that is available as a part of H2, in the situation when all your data is stored in Java heap, which is known as on-heap mode, on-heap cache mode in Apache Ignite, For this situation, we have two different implementations. The first implementation is AVL tree based implementation with fast cloning capabilities. Also, we call these indexes as snapshotable indexes due to the way how AVL tree with fast cloning capability actually works. The other approach, the other implementation that is available to Apache Ignite users and enabled by default is based on a skip list data structure. And actually here, Ignite simply uses concurrent skip list implementation that is part of basic Java development kit library. It's basically there are a lot of discussions and arguments around what kind of data structure suits best for indexing purposes. And for some scenarios, you may want to use AVL tree, while for the others, concurrent skip list may be much more applicable than the tree. So it's up to you. And here I don't have any specific recommendation on when to use what kind of the indexing model to use in your use case. You just need to review and to use the index implementation that suits your use case most. However, for the case when all your data is stored out of Java heap, when it's stored in off-heap region of the cache, then for this scenario, Ignite provides only AVL tree-based implementation for the indexes. So there are, as you see, there is no a lot of the choice, but in any case, the AVL tree with fast cloning in off-heap mode shows perfect performance results, and it shouldn't prevent you from using off-heap rather than on-heap. So next, that's all, guys, for the internals of the Apache Ignite SQL engine. And now I would like to move on and cover how the query execution flow actually looks like and being implemented by Apache Ignite SQL engine. So if to take a look on the picture to the right, the execution flow, the default execution flow is quite straightforward. So let's imagine that your client application that is shown on this side decides to execute a query, some kind of SQL query. And this query is being sent without any modification to all the cluster nodes that store data that is going to be queried by the request. After that, when every node receives this query, it will execute this query over the local data set only, over the data set that is available on this node only, and will return a partial result set to the client. And after that, when client receives all the result sets from all the cluster nodes, it will return it back to your application layer, and you will be able to iterate over the final result. And here it was to mention that the client side doesn't preload all the result set immediately from the cluster nodes. It preloads it in a paginated fashion. So depending on the result set page size, which is configurable, it will preload the result set making sure that all the data set will fit into the memory of your client application. And in fact, the flow that is shown on this picture is called as collocated queries mode, meaning that the query that can be executed from the client side may join data between different caches. Let's say it may join data between the caches that store data for organizations and for employees. And for this scenario, all the data has to be collocated, meaning that if you want to join organization with their specific employees, then all the employees has to be located on the same nodes where their organizations reside. Otherwise, you will get an incomplete result set, or wrong result set. The data collocation topic is quite extensive, and I'm not going to cover it during this webinar. You can simply take a look at a variety of examples and documentation that is available on Apache Ignite site to get to know this concept better. However, there are situations like I told, it's preferable, right? So if you're going to join data between a variety of caches, and this in any case you will have at least one join, right, in your application, then you should try all your best to collocate the data, making sure that the SQL queries will be executed in the most performant way. However, there are, in my experience, users are able to collocate all the data in such a way that around 95% of all of the SQL queries is possible to execute in a collocated fashion, but there are always around 5 or 3% of SQL queries that are left and that they were not able to execute due to the fact that it wasn't possible to collocate the data to execute that queries. And to address this issue and to be able to support the execution for all the imaginable queries in Ignite, starting from Apache Ignite version 1.7, we introduced so-called non-collocated mode. And the difference between this mode and the previous mode we were covering a couple of minutes ago is that if you take a look at the picture, you will see that in this scenario, let's say if node 1 during the execution of the query will find out that there is some data, that some data is missing, and this data is required to complete the join between two caches, then this node will send additional request to the rest of cluster nodes asking for the missing data. So, and here you may face with performance bottlenecks depending on the amount of data that may be moved and transferred among the nodes. And so, and this is the reason why you should use this mode only for the scenarios when you are absolutely sure that there is no any way to collocate data and to execute collocated mode. So next and final thing that we should do that is related to the query execution flow is about local queries. So Ignite local SQL queries are simply to enable by setting a specific configuration property for an SQL query. And when you try to execute a local SQL query, the query will not use Ignite's distributed reducer or mapper or other components that are needed, to make sure that the query that is executed in a distributed fashion returns a complete result set. When you execute a local SQL query over Ignite, the query is basically moved directly to H2 database and executed by it over the local data set. So, and actually these local SQL queries are executed when your query should query the data located in a replicated cache, and since the replicated cache is the data for the replicated cache is by default available on all the nodes, then there is no any sense to distribute the query, and it absolutely fine to switch to the local query mode and execute it right away. And next, the other applicable use case is when you want to, and when you know that you have a number of caches, and you collocated all the data among all these caches, and you just want to be sure that the query, and you just want to send an Ignite Compute distributed closure to specific node and execute some local SQL query as a part of some complex execution that is implemented by a distributed closure. And in this scenario, you can also use local SQL queries, but you have to use Ignite Compute's affinity run method, because it will make sure that the partitions, the data grid partitions, which are actually being queried by local and other SQL queries, are not moved during the query execution if the topology changes, if a node joins or leaves the cluster. So, okay, moving forward, what is the API that is available to you? So the first thing to note is that Apache Ignite SQL engine provides unified multi-language API for Java and Scala programming languages, as well as for .NET and C++. From this, using the APIs directly from these languages, you can rely on the queries of two kinds. The first one is SQL query and the second one is SQL fields query. The difference between these queries is that the SQL query returns you the complete entry, key and value that is stored in a cache in the result set. While if you use SQL fields queries, as it's shown on the example to the right, you can define the keys, the fields that you want Ignite to return you in the result set. And next, query entities is a specific component of the Apache Ignite SQL engine, and this class is used to define queryable types. So actually, the data types that are stored in your cache, and it allows you to define fields and indexes for these types. However, even more, as I briefly mentioned at the very beginning of our webinar, if your goal, if you don't need to write an advanced logic to work with Apache Ignite cluster, and you would like simply connect to Ignite cluster and query some data from it using SQL language, then you can connect to Ignite cluster using either JDBC or ODBC driver and execute your SQL queries right away. And here you can use, and this is how you can connect to Ignite from Python, from PHP or other language, or from the tools like Tableau that are widely used for analytical purposes. At the implementation level, just a couple of words about our drivers, Apache Ignite drivers. The implementation layer, when you connect to the cluster using JDBC driver, the driver implementation simply starts an Ignite client node, which connects to the cluster. And basically, all the queries that are sent over the JDBC driver are redirected to the client node that finally sends SQL fields query to the cluster. The ODBC driver implementation is a bit different. And the difference is that ODBC driver opens a special TCP IP connection to the cluster. And on the cluster side, there is a special component called ODBC processor that has to be started. And this processor listens for incoming connections from ODBC driver side and processes all the queries that are being exchanged over that TCP IP connection. So that's all about the SQL engine at its current state. And let me briefly give you a couple of optimization and debugging related suggestions. So the first general suggestion is it's obvious fact that you have to set up indexes, right, for your SQL queries if you want to get your data back quickly. However, in some of the scenarios when your query uses several indexes, it makes sense to think about and to introduce group indexes, because group indexes may perform faster rather than when you use several index fields in your queries. However, opposite side of indexing is that you don't need to index every field, right? Because the indexes are not given for free. Just keep in mind that every time when you update the data in your cache, Ignite has to update indexes as well. So make only those fields indexable that will be used in your queries, and you are sure that they must be indexed. Next valuable suggestion is that if your data is stored in off-heap space, then you may want to tune on-heap raw cache size. The situation here is the following. When the query is being executed and all the data that is in off-heap, and when the index is allocated in off-heap, we have to bring off-heap indexes at our current implementation from off-heap space to Java heap. And that on-heap raw cache actually defines the size of the space that is booked for the indexes that are moved from the off-heap, for the rows of the indexes that are moved from the off-heap space to on-heap during the query execution. And this on-heap raw cache is implemented as a less recently used cache. And the final thing is that try to collocate your data, right? Like I shown on the previous slide. It's preferable to use if you execute joins, then it's preferable to use as a collocated mode, because during the join you will avoid data movement between data nodes. And as for the debugging, if to give a couple of suggestions related to the debugging of your SQL queries, if you see that your query is the performance of your SQL query is not satisfactory, it makes sense to double check that the execution plan properly chooses indexes. And to answer on this question, you can use explain statement that is available on Apache Ignite SQL engine, since it's NC99 compliant engine. As well, at the early beginning of the development cycles of your application and solution, sometimes it makes sense to debug your SQL queries using different monitoring tools. And here you can use GridGain Web Console that I'm going to demonstrate in a couple of minutes. And this console allows you to execute queries over the cluster and to see the result cell returned by the queries. And even more, it allows you to monitor the queries that are being executed over your cluster. And after that, since all we right now know that H2 is used by Apache Ignite SQL engine, you can connect to H2 on a local node and to debug and do some low-level debugging if it's needed. So, and before we switch to our demo, I want to just share with you some interesting stuff on what we are going to support in the nearest future. As I mentioned earlier, presently it's possible to connect to Apache Ignite using JDBC or ODBC driver and execute SQL queries from your favorite tool or from your favorite technology for which we don't provide direct library or API. However, starting from Apache Ignite and 8.9, it will be possible to execute, insert, update, and delete queries using our JDBC or ODBC drivers, and even more. The next year, Apache Ignite will provide support for data for the structure modification language, and it will be feasible for you to create caches or modify indexes using DDL statements. So there won't be any need to use direct cache APIs or cache configurations. So you will be able to connect to your cluster from JDBC or ODBC and modify a query and update the structure from your tool or from your Python or PHP application. So that's all for the theory. Let me briefly show you the demo. Okay. So I'm going to use GridGain Web Console that is available for Apache Ignite for free. So basically you can go to main Apache Ignite site, go to manage section and click on GridGain Web Console. So it's available for free in the hosted mode. So you may want to open it and to connect to your cluster directly from this console. And here I'm going to show a demo that is already available as a part of the web console. So the demo says that I need to download a special web agent. It's a special process that stays in between the cluster and web console and make sure to connect both parties. So I'm starting the Ignite web agent. It will connect to my console in this address. By the way, Lisa, do you see my screen? Just want to be sure that.
Yes, I see your screen.
Okay, thanks for confirmation. Okay, so the web console is up and ready, and they are ready to proceed with our demo. So let's wait for a couple of seconds. The demo is starting the cluster nodes. As you see, at the moment we have only one node in our cluster, but as far as I recall, there should be more than one. Let's wait for some time. Okay. The nodes join the cluster. And let's switch to SQL Query tab. The SQL Query tab here defines, so the demo already created a couple of caches. You can take a look at the fields that are available for every cache. And using these fields, you can query the data, like this one. presently we count just data, that is all the data, all the cars numbers that are located in the cars cache. In addition, you can directly from this console, you can execute, explain statement, and see the execution plan produced by H2 database. However, here, as you see, we don't use indexes, and the full scan is used during the query execution to make sure that let's take a look on how the execution plan will look like if we use some indexed field in our query. So I will type where key. So the key is a special keyword. So, and it's kind of a, it's always indexed. And this is the key that is used at the time when your entry was placed into the cache. It's always indexed and it's always available. So let me execute the query. So yes, I found a number of entries, and let's take a look at how the execution plan looks like. So here you see that we used the indexing. We used this key that was an indexed field, and the execution plan used indexes and in fact returned the results set much faster, much more faster. So next, what else interesting here? The next example that is available here shows how you can join the data between different caches. So here we have a kind of the cache for cars and the cache for parking, and we are trying to find out how many cars are parked in a specific parking space. So you can execute it. You can take a look at execution plan and so on and so forth. So that's it from my side for today. So, and I'm ready to answer on your questions.
Okay, I'm going to go ahead and start to read some. There's a lot of questions, so I'll just start at the top and we'll take as many as we can. So the first question is, can the console be hosted on their own network?
Yes, the console can be installed on premise. However, presently, if you want to use the console on premise, you have to use GridGain rather than Apache Ignite. So the on-premise installation is not free. What is open source is hosted deployment of the console.
Okay. Next question: How does cache redundancy work with this?
Cache redundancy. So basically, this kind of generic question, and I don't know how it relates to.
Somewhat he just expanded. He said that is if the data node is down and it is in the query.
So, and here everything is simple. The query engine subscribes and listens to internal notifications that are exchanged among all the cluster nodes. And if during the query execution, the query engine receives the information that some of the nodes, when the query were being executed, went down, then the engine will redistribute this query and will make sure that the result set will still be consistent and correct.
Okay, the next question. Can the SQL queries be supported when using binary objects? How should indexing be created for binary objects?
Binary objects is a kind of, there is no any difference on whether you use binary objects or if you use objects that are marshaled, that are serialized using Java marshaller or .NET marshaller, in fact. So to define, you can define indexes using annotations in the same way like I was shown during the slides, or you can use query entities. What I would suggest is to go to Apache Ignite README.io, and there is a section called Binary Marshaller, and here we should have, let me see, no, we don't have it here. We have SQL queries, and for SQL queries, we have, 1 second. Here it is. We have a section that shows how you can define indexes using query entities. So it's up to you. So for binary objects, if you still have classes, right? If you have Java classes for your binary objects, then you can define the indexes directly in the code, as it's shown here. Or if you prefer to define indexes in the configuration, or if you don't have classes for your objects, you can use query entities, like it's shown here in this example. Hope that I answered on your question.
All right. The next question, does Ignite support order by, and how does it work with pagination?
Yes, the Ignite supports order by. And as for pagination, as far as I recall, but I might be wrong, so if you use order by, then the result set should be, I should double check it. So, but in my understanding, the most straightforward solution is to load the result set back on the reducer side, but it may lead to insufficient memory situation. So, and here I guess that we have some tricky algorithm, and I would encourage you to write a question to our dev list, and I hope that our SQL engine maintainers and contributors will be able to give you a precise answer on how it's actually implemented, how we make sure that order by works properly with pagination. But in general, yes, it works. So.
Okay, I think we have time for 1 or 2 more questions. Isn't collocations and distributed data contradictory? With large data sets that are distributed naturally, are there any special patterns that Ignite provides to make join queries efficient?
So actually, as I mentioned, the most you will get your SQL queries that uses join will be the most efficient if you use so-called collocated mode, which is in fact enabled by default. And here there is no any specific pattern. Here you just need to make sure to collocate your data. Here we have a special topic called affinity collocation. It provides a couple of examples. So like it's shown on this example, you collocate persons with their organizations, and later on, when you execute SQL queries that joins data between persons and their organizations, this will be done in the fastest way, because there won't be any data movement because all the data is collocated. However, if you don't collocate your data, if you, for example, forgot to collocate persons with your organization, and if you still keep using the collocated mode, then you will get an incomplete result. And to fix it, you have 2 options. You either have to collocate the data, which is a recommended way, or you can enable SQL queries distributed non-collocated mode. And to learn more about non-collocated mode, you can go to SQL queries, documentation, open distributed joins, and here we are talking about this topic, and here it's shown how you can enable non-collocated mode for your SQL queries.
Okay. Great. That brings us to the top of the hour. I want to remind the audience that we have a related webinar on November 30th. It's called Tuning Apache Ignite for Optimal Performance. And I invite you to register. And if you can't make the date, go ahead and register anyhow, because we'll send you the slides and the recording afterwards. So you can find that on www.gridgain.com under the webinars. So with that said, I'd like to thank you for attending today's webinar. I hope you found it informative and enjoyable. And Dennis, thank you for a great session. And audience, we hope to see you again.
Thanks everyone for attending.
Okay. Thanks everyone. Bye-bye.